Humans have tried for thousands of years to understand its vastness. We point our telescopes at it, we send our spacecraft into it. And yet its impossible largeness eludes us. Journey with us now as we take an hour out of forever to see how big is really big and how far is really far on Unraveling the Cosmos. $3.7 billion miles away from Earth. $2.8 billion miles. As we travel toward our planet from beyond the orbit of Pluto, we can't help but wonder, if the distances in our own solar system are this great, just how vast is our universe? And is there anything beyond it? Jupiter, nearly 500 million miles from Earth. An asteroid belt, 173 million miles from Earth. Closer to home, we see Mars. Built deep in our souls is an unquenchable thirst to explore, to go beyond what's known and expand our knowledge for all mankind. In 1962, President John F. Kennedy challenged our natural spirit of exploration with his famous moon speech.
Well, space is there, and we're going to climb it. And the moon and the planets are there, and new hopes for knowledge and peace are there. And therefore, as we set sail, we ask God's blessing on the most hazardous and dangerous and greatest adventure on which man has ever embarked.
Just 7 years later, in the summer of 1969, a Saturn V rocket, the most powerful man had ever built and as tall as a 36-story building, launched 3 men into the most ambitious space adventure yet, to the looming sphere that has enabled us to mark and record the passage of time for thousands of years. The moon. It took nearly 3 days to reach our nearest neighbor in space. Meanwhile, millions of people back on Earth held their breath as every passing hour took mankind further than ever before, on a journey that carried 1,000 years of human dreams and aspirations. Then, in one brief, awe-inspiring moment, that one giant leap for mankind forever changed our sense of what's possible. To grasp the profound expanse of space, let's start in our own neighborhood, with the only two places where man has ever set foot. The moon is Earth's only natural satellite, and a large one at that. About a quarter of Earth's diameter, it's the fifth largest moon in our solar system. It is so big and so close, it actually pulls on our planet, guiding the ocean tides and even stabilizing the Earth. The moon is about 239,000 miles away, but in space terms, they're practically on top of each other. If the moon was a tennis ball sitting way out here beyond the three-point arc, the Earth would be roughly the size of a basketball resting on the rim. That's 24 feet away. So far and yet so very close. Without the moon's gravitational pull, the Earth would tilt and swing wildly on its axis instead of modestly wobbling. If Earth were to tilt too much, the amount of sunlight reaching its surface would change, causing vast amounts of ice to shift between the poles and the rest of the planet. This would profoundly affect Earth's delicately balanced climate. Fortunately, the moon keeps us safe from chaos and instability in our climate. Locked in an ancient continuous orbital dance, the Earth's gravitational forces exert a pull on the moon, keeping it circling our planet like a ball on a tether, instead of flying off into space. It may be difficult to imagine, but the moon is traveling around the Earth at more than 2,200 miles per hour, much faster than a speeding bullet. Yet the moon seems to have no perceivable motion when we look at it from Earth. From here, the moon always appears tranquil in our sky. In fact, all objects in orbit around our planet appear equally tranquil. But looks can be deceiving. When we see footage of the International Space Station or the recently retired Space Shuttle orbiting quietly 250 miles above the surface of the Earth, it's hard to get a sense of just how fast these spacecraft are going. In reality, they're traveling at about 20 times the speed of a bullet. The astronauts aboard the International Space Station can watch a sunrise every 90 minutes. Suppose the shuttle were to orbit the Earth a little bit closer to its surface. What would 17,000 miles an hour look like from down here on the ground? You'd have to know it was coming and from which direction. Buzzing the Earth at 5 miles a second, you wouldn't hear it until it flew past you. And by that time, it would disappear over the horizon before you had a chance to turn your head. Now we have a better sense of distance in space and the speed that made it possible to visit our nearest neighbor, the Moon, in just 3 days. When we come back, we'll visit our most important neighbor, 93 million miles away, the Sun. This is the star of our solar system. Without the Sun, the Earth and Moon would be nothing but cold, dark rocks, drifting aimlessly in space. Long before a Renaissance mathematician claimed that the Sun was the center of our solar system, man has known the value of this golden orb in the sky. He didn't need an orrery, a clockwork model of our solar system, to know it's the Sun that provides our light and heat. Even though there are hundreds of billions of stars in our galaxy alone, the Sun is the most important. To us, anyway. A visit to the Sun isn't possible, of course. It has no solid surface, just a broiling hot mass of gas called the photosphere. And the closer you travel to the solar core, the denser that gas becomes. More than 100,000 miles down into the Sun, you'd reach the radiative zone, where thermal radiation travels outward from the center. If you kept traveling inward, you'd reach the thermonuclear powerhouse itself, the Sun's core. It's 27 million degrees Fahrenheit down here. This is where all the light and all the heat that we receive on Earth is created. The Sun is about 4.5 billion years old. In another 5 billion years, it will burn up most of its fuel, causing it to cool and expand into a red giant star. Mercury and Venus, millions of miles away, will be swallowed by the Sun in this expansion. Just how big is this massive burning ball of heat? In our solar system, it's the biggest thing there is. Here's Mercury, Venus, Mars. Now let's bring in Jupiter and Saturn, our two largest planets. As you can see, they simply can't compare in size. The Sun is so big and powerful, it builds up magnetic energy. This generates spectacular eruptions of intense, high-energy radiation. These are called solar flares, and they are dozens of times larger than the Earth itself. If you've traveled to the other side of the world in a commercial jet, you know it's a very long flight. Flying non-stop around our planet would take more than 45 hours. That is almost 2 days in an airplane. With a circumference 109 times larger than that of the Earth, a flight around the Sun would take about 200 days. On hot summer days, we can still feel the sun warming our skin, even though the source of that heat is 93 million miles away. Fortunately, our planet is just the right distance from the flames of this stellar oven. Not too close, but not too far. In fact, if the sun were to suddenly stop shining, it would be a full 8 minutes before we'd notice anything was wrong back here on Earth. The sun's enormous mass exerts a gravitational pull that forces the planets to orbit around it. When we see scaled models or illustrations of the planets orbiting the sun, it's impossible to get a true sense of the distances involved. They're just too vast. If we were to blast off from the sun and take a tour of our planetary neighborhood, traveling at the speed of the Apollo rockets, it would take 60 days to reach the closest planet, Mercury. But we would need to settle in and get comfortable because we've only started. It's 112 days to get to Venus. After 5 months of travel through space, we'd reach Earth. Then 3 months later, we could look forward to seeing Mars. But we wouldn't reach Jupiter for more than 2 years after our initial blastoff from the sun. And it would be another 2 years before we'd get to Saturn. Then 4 years after that, we'd finally reach Uranus. If you really want to see Neptune, it will take more than 13 years traveling in space, and a total of 18 years to reach Pluto, almost 4 billion miles away. Our solar system is vast, yet it's just a grain of sand in our own galaxy. Our bright, burning, familiar sun simply disappears among the billions and billions of stars in the Milky Way. Just how deep into space has man's fastest spaceship traveled? We'll find out next. After a long journey from our sun to the outermost planets, we have a better idea of how far apart these bodies really are. And what we've seen hasn't changed very much during the last 3 billion years of our solar system's history. But on its fringes, in a band called the Kuiper Belt, things aren't nearly as stable. Here you'll find several dwarf planets, including Pluto, as well as millions of frozen objects tumbling through space. These are icy planet leftovers that date back to the formation of our solar system, around 4.6 billion years ago. Here, these objects remain in a stable orbit beyond the planets of our solar system. But occasionally gravitational disturbances from Neptune or Uranus will hurl these so-called dirty snowballs into the inner solar system, where they become short-period comets. Most last just a few years before breaking up as they draw closer to the heat from the sun. Solar heat causes the outer layers of these icy bodies to evaporate, releasing gas and dust. Solar winds sweep these particles into a long tail, pointing away from the sun. In 1977, NASA launched two deep space probes, Voyager 1 and 2, which are traveling at 35,000 miles an hour, twice the speed of the space shuttle in orbit. After several decades in space, the Voyager spacecraft have already passed the outer limits of our solar system. They've passed the Kuiper Belt, and they are approaching interstellar space. Their mission: to explore the limits of the sun's magnetic field. Beyond the Kuiper Belt, at the edge of the sun's kingdom, is a gigantic structure known as the Oort cloud, which begins 465 billion miles away from the sun. This is the outer solar system's icy shell, and it's where comets with much longer orbits originate. One such comet, Hale-Bopp, came out of the Oort cloud and blazed a long, bright path toward the sun. In 1997, Hale-Bopp became visible to the naked eye when it swung near Earth, though it was still more than 100 million miles away. The last time Hale-Bopp came this close to Earth was 4,200 years ago. The ancient Greek and Roman empires were yet to be born. Hale-Bopp is now drifting back to the Oort cloud, freezing over once again, and no longer blazing a bright trail through space. And it won't be back for another 2,400 years. Just how many of these icy planet leftovers, these potential long-period comets, are floating in the Oort cloud? As many as 1 trillion. Think of it this way. There are 3.25 million crystals in a 5-pound bag of sugar. It would take about 325,000 5-pound bags to make 1 trillion sugar crystals, the number of comets in the Oort cloud. The Oort cloud is so massive that it's believed to stretch 1/3 of the distance to Proxima Centauri, the next closest star to us after our own sun. But our nearest stellar neighbor, just 4.3 light years away, is still a long way off. It would take the Voyagers 1,500 more years just to reach the beginning of the Oort cloud. To get to Proxima Centauri, it would take another 80,000 years. That's twice as long as the emergence of prehistoric man from caves to our present-day civilization. To travel from our planet to the next group of stars, 4.3 light years away, you'd have to cover more than 25 trillion miles. To make a trip like that, we would need a spaceship large enough to carry generations of space travelers. A spaceship as large as a city. As history has taught us, the idea of a heliocentric system, where the planets revolve around the sun, was a dangerous concept during the Renaissance. Just a few hundred years ago, in 1592, there was an Italian philosopher who dared to suggest that the sun was just another celestial star in the sky. That idea did not go over too well at the Vatican. After a lengthy trial, the Roman Inquisition found Giordano Bruno guilty of heresy for his belief that the universe was infinite and that the stars were not all the same distance from the Earth, but simply other distant suns with their own planets revolving around them. Bruno paid for this with his life. In the year 1600, he was burned at the stake. To truly measure the vast distances between stars and galaxies, we're going to need a longer ruler. A measure in distance based upon the speed of light. Light travels at approximately 186,000 miles per second. If we fired a pulse of light from the Earth to the Moon, only 239,000 miles away, light would hit it in about 1.3 seconds, practically the blink of an eye. From Earth to Mars, an average of 139 million miles away, that same pulse of light would take almost 13 minutes to arrive. To Jupiter, over 30 minutes. To Saturn, an hour and 10 minutes. And to reach the frozen world of Pluto, even at light speed, would take nearly 5.5 hours. Outside our solar system, the distances grow exponentially, so we need an even bigger unit of measurement, the light year. This is the distance that light travels in 1 year. Remember Proxima Centauri, our nearest solar neighboring star? That's 4.3 light years away, over 25 trillion miles. But why set our sights so close? With every passing week, astronomers are discovering new and distant worlds called exoplanets. "20 light years from Earth, in the constellation Libra, there is a red dwarf star named Gliese 581. Scientists believe an Earth-like planet may be in orbit around it. With the right atmosphere, this planet may be able to support human life. What would it take to travel there? Let's imagine that 100 years from now, we are able to build a starship capable of traveling at 10% of the speed of light. That's fast, but it would still take hundreds of years to reach even nearby exoplanets. The ship would have to be miles long, the size of a small city, completely self-sustaining, and capable of traveling vast distances over many human lifespans. You would need a ship capable of sustaining thousands of crew members, multiple generations of people, for its 200-year journey. Like workers who built great medieval cathedrals, but never lived to see them completed, your children's children's children would travel their entire lives on this interstellar arc. They would still never see Gliese 581. They'd only be halfway there. And this is just a short journey in the grand scheme of space. Our solar neighborhood extends 5,000 light years across, and that's just our corner of the galaxy. To cross this neighborhood, humans would embark on an epic migration aboard this giant space colony. Our noble explorers would leave Earth forever, knowing that inside this ship they carried future generations on their shoulders. Onward, toward a distant world, where humanity might live and prosper on land again. The generation ship would continue on, traveling vast distances through space at tremendous speeds towards its destination. A strange new world that the passengers and crew could only dream of. It may seem like an infinite journey, yet it would cover just a fraction of the Milky Way. To go outside our galaxy, we'd have to power up our ship to unimaginable speeds to reach deeper into space. We are just beginning to get a sense of how big our galaxy, the Milky Way, really is. Looking into the sky at night, we can sometimes see it from here on Earth. That disc-shaped island in space gets its name from the faint band of milky light stretching across the sky. Those large, bright spots that look like stars, they're actually clusters of stars. Millions of them. This is just the galactic center, the brightest part of our galaxy. We can't see all of the Milky Way from here on Earth because we're in it ourselves. The Milky Way is all around us. Who could blame our ancestors for believing that Earth was at the center of our universe? Our sun rises every morning and sets every evening, offering a glorious nightly glimpse into the celestial heavens. But this sun, when it's not set against a picturesque sky of blue as seen from Earth, becomes in the blackness of space just another one of the hundreds of billions of stars in the Milky Way. When we look up at the distant stars, we know they are trillions of miles away, but they are only distant from our vantage point. From another view, deep in space, our sun becomes the distant star. To take in this view of our colossal Milky Way, you'd need to be millions of light years away. The sheer number of stars, the clusters, the constellations, the solar neighborhoods simply overwhelm the senses. Where's Earth, the sun, and our solar system in this picture? don't even try. Our Milky Way is 1,000 light-years thick and 100,000 light-years in diameter. How do we even begin to put a number like that in perspective? Let's just start with the number itself. 100,000 light-years is roughly equal to 600 quadrillion miles. Still, what does that even mean? Let's look at it this way. If you were to sit down with a pen and a very long strip of paper, and you had the time to draw 600 quadrillion tiny figures, say the 11 astronomical symbols of the planets in our solar system, repeating endlessly, that strip of paper could wrap around the sun more than 3,000 times. Now, instead of those little symbols, try to imagine 600 quadrillion miles. That's how wide the Milky Way is. Still doesn't help much, does it? At the heart of our galaxy is a bulge of billions of older stars known as Sagittarius A. It's home to one of the most energetic and mysterious phenomena in all the universe. An ominous and violent supermassive black hole. Here, gravity is so strong, even light cannot escape. Black holes at the core of spiral galaxies like the Milky Way cannot actually be seen. But scientists are able to detect them by watching the behavior of nearby stars as they are being pulled toward the black hole. Just before they are swallowed, they create massive amounts of radiation. More than 4 million times the density of our sun. The black hole at Sagittarius A is where stars and massive star clusters disappear without a trace, and where time and space cease to exist as we know them. As big as the Milky Way is, it's staggering to think that our galaxy is just an ordinary spiral in our little corner of space. Let's say our generation ship got a major tune-up, and now it's cruising at near light speed. It would still take 2.5 million Earth years to reach Andromeda, our nearest neighboring galaxy. Even at the speed of light, your progress would be barely perceptible in space. If everything goes perfectly, your descendants will arrive through a wormhole in the strange new galaxy of Andromeda. Hopefully, they'll have found a habitable planet. And they would have to be prepared to leave the ship, to discover food supplies, establish shelter, and recreate and form societies. The culmination of a mission millions of years in the planning. Imagine arriving on a strange new world, an Earth-like planet perhaps with entirely different life forms, where evolution took a very different turn. For now, that's the stuff of dreams. But so too was a trip to the moon not so long ago. What does the future hold for our species on Earth? Might such a journey to a distant world one day be necessary? A journey to beyond what we can see. We know space is big. But just how much space is out there in the universe? Next, we'll explore so deep into the cosmos, there isn't a spaceship that can take us there. And we'll look almost all the way back to where time and space began. In 1923, a young astronomer named Edwin Hubble was working at an observatory in Mount Wilson, California, when he looked deep into space and recorded what he thought was a formation in the Andromeda Nebula. The American astronomer then took a series of simple black and white photographs that would soon make history. He didn't know it right away, but Hubble had just made one of the most important discoveries of the 20th century. Andromeda was not a cluster of stars within the Milky Way. Edwin Hubble had located another galaxy. But just how many galaxies are there beyond the Milky Way? In 1990, NASA launched a powerful orbiting telescope named after Edwin Hubble to peer into the deepest reaches of space. The size of a school bus, the Hubble Space Telescope orbits outside the distortion of the Earth's atmosphere. For 2 decades now, Hubble has been capturing and sending back to Earth the most stunning and informative images ever taken of the cosmos. From the Ring Nebula in the northern constellation Lyra to large star clusters surrounded by radiant gas, all that remains from the explosion of massive stars, to the Whirlpool Galaxy, to gigantic gaseous pillars of radiation, to open clusters of stars in near and distant dwarf galaxies, the Carina Nebula, 3 light-years tall. Spiral galaxies, 30 million light-years from Earth. Hubble produced one miraculous image after another. But one image from the Hubble telescope, captured and assembled over a 4-month period in 2003, is every bit as momentous as Edwin Hubble's groundbreaking 1923 image of the Andromeda Galaxy. On first glance, it appears to be nothing more than stars in the night sky. But a closer look reveals more than 10,000 objects. These aren't stars, or solar systems, or even star clusters. Nearly every one of these tiny balls of light is a galaxy. Hubble scientists have named this image Ultra Deep Field. What's most remarkable about this Hubble image is that the 10,000 visible galaxies in this single frame account for just 1/24 millionth of the whole sky. To capture this image, NASA astronomers pointed the telescope at a very small, dark, and seemingly empty patch of southern sky, then waited. They had no idea what that darkness would reveal. To get an idea of what Hubble was focused on, imagine you're an astronaut floating in space. You hold up a pencil at arm's length, and behind your eraser, in that tiny patch of space, were those 10,000 galaxies. Then, faintly in the image, astronomers were able to detect more than 5,000 additional galaxies, including some of the earliest born. You might say they are the baby pictures of the universe. Light from these galaxies has been traveling to us for more than 13 billion years, taking us almost all the way back to the Big Bang. How many galaxies are there in the known universe? Until Edwin Hubble came along, astronomers thought there was only one, the Milky Way. But NASA now estimates that there are hundreds of billions of galaxies out there in space. So, is there an end to the universe? And if so, is there anything beyond that? All bets are off here, as scientists are still trying to figure out the vast complexities of an expanding universe. The size of space is far greater than what we can imagine. But as we continue to follow our natural instinct to explore, we are getting closer and closer to unraveling the cosmos.